This is Miguel Anjosa. Today I'm having this presentation with Murilo. Hi, Murilo.
Hi, Miguel.
Hi. Well, last week I did a similar presentation. Today again I'm going to talk about compaction, theory and application. As I mentioned before, this is not going to talk. I'm not going to talk about vibration or amplitude, frequency, not those kind of concepts. I'm going to talk about more about the theory of compaction and the machine application itself. So it's going to be quite different. I don't know if you get to the opportunity to see my previous presentation, but of course you will find it there also in this YouTube channel. Then again, thanks again for joining for this presentation. We will try to answer all your doubts, questions, comments you have. You can leave them in the chat box of the YouTube. Please remember that to leave a message you have to, or you need a YouTube channel account. It doesn't mean that with your Gmail you can leave a message. You need your YouTube channel account to be created. You just pop up there, there's a pop, it will pop up to message. Please continue the instructions, you create your user, and it will allow to subscribe to our YouTube channel as well as to leave the comments or message or questions for us. Okay, Murilo will help me a bit with those questions. Maybe at the end I will continue with the presentation. In the between, maybe he will also join. Thanks for your time. I think it's, I don't know, maybe it's morning for you, afternoon, or even quite evening. Here is quite early. We're 6 a.m. here in Brazil. Now we are waiting to see how many people it's there. Okay, so I'm going to give 1 more minute so we can have more people join, and then we will start rolling the presentation. Please do leave your questions once again in the chat box or comments. Also, you have any further questions, you can see below my email. So send your questions to me, your comments, or any information you would like to have about this presentation. So let's see, how many people do we have now? Well, we have few people today. I think we can start already. Let's see. Okay, I will start. Murilo, please keep in touch. Okay, let's start. Well, what is compaction theory and application? What I'm going to talk today about. It's mainly about what I was mentioning before. It's not about frequency, amplitude. I'm going to talk about a general theory about the theory of compaction itself, and a bit about application. So I have some general tips in the operation of the machine, some additional information you may need to know when you go into the field or when we have some questions from our customers. But where does compaction begins? We begin with the soil compaction. Okay, so we're going to start with this one first. So when we're talking about road construction, what does soil compaction mean? Well, usually we begin with moving the earth, of course, moving the material we are going to compact. Then we are going to level up a bit the material, and then we are going to compact the machine. So here is where we come. We are the ones responsible to do this. But what do we use? Depending on the material we are going to work with, we are going to use a smooth roller or smooth cylinder roller, or we are going to use a cylinder with pad shells, or maybe we are going to use a CT3000 that it's a tamping roller. So depending on the material we're going to work with, we have to select the correct machine for the project. So which machine should we start with? Or first, we have to define what is compaction. So what is compaction itself? We have the material, loosened material, and this is compound or made of soil particles, water, and air. So what we are going to do is to use mechanical forces to pull out the air and increase the density of the material. So here you have the loosened material. We have material in its normal form, is it a natural form, and we are going to use through vibration we are going to accommodate the particles. You can see they moved and they are one above each other, and also through the impact or the force we are going to pull out the air and we are going to increase the density of the material. But you can see water. So what remains here is the water that is going to act like a lubrication itself in the material. So this is compaction. And what can we do in compaction? What can we affect? How can we affect the compaction? So actually you have three parameters that you can directly affect compaction. The first one is the quantity of moisture you are going to have in the material. This is something that is usually handled at the lab, and if not possible, you can you can actually see it on the field also, how much moisture of material you have. Then you have the effort of the or the effect of the compaction effort. This one means how much force I'm going to use to compact the material. And then we have the effect of the compaction type. So here we have, depending on the machine, what type of compaction we are going to apply to the material. So actually here you are going to select the machine for the material or compaction needed. So once again, what we were talking about, it's like we have the material that is made of soil particles, water, and air, and we are going to increase the density. But what does it mean? Well, you have the dry weight of the material or the dry unit weight and compared to the maximum water content. Okay, so what happens here is like you are having the dry material, you start adding water. Okay, and the more you add water, the more density you can reach. So you continue adding water and you continue increasing the density of the material. So here you have to take care of this control. How do you do this? You do this through the Proctor method. So the Proctor method was created around the 1930s, if not mistaken, in 1933. And this engineer, Proctor, he developed a method to check how much water do you include in the material before reaching or up to reaching the maximum density of the material. So when you reach this point, before reaching this point, you are dry of the optimum moisture level or wet of the optimum, because if you have too much water, then again you will lose the stability of the material, so you will lose density here. So you have the highest point, you have to calculate it, and this is where you are going to work, and this will be your comparison or your point of measurement when you are talking about compaction. So what I was talking about here is like when you have the Proctor, you are talking about the energy you are going to use to compact this material. So the standard Proctor developed in earlier years, you have this weight dropped from a height of almost 30 centimeters, and you have material and you will impact with this weight the material. So you know this creates some energy. So this dynamic energy you are using to compact the material will create a curve here that you can see, of course. So you are increasing the quantity of water and you can measure how the density is increasing. And then you are in the Second World War, we had bigger machines, we have bigger airplanes, bigger trucks, more load. So he needed to develop a test that could handle this new quantity of load or the force you are having that will the material will have to support. And he created a modified Proctor, and he increased the energy, okay, and the quantity of layers. So this way you can measure, you can have what we are talking about, the modified Proctor. So with more energy. Actually, you can see here that from the standard to the modified, you have more energy needed, okay, but with less quantity of water. But what happens if you continue adding water? So if you continue adding water, you will start losing your stability, you will start losing your density of your material, and then it doesn't matter how much energy you use. You won't be that far between standard proctor or modified proctor. You will have almost the same results. So in the beginning, yes, it can be that with more energy you can reach faster higher density, but then later you will have these different issues here with too much water. You won't reach this, and well, you have zero air void line when you are actually removing all the air from the material. Okay, this is almost a vacuum state. Okay, so you have here the pictures of standard and modified. You can see here the 3 layers, and these tests let us know how much energy you are going to apply to the material. Okay, so actually in the field, how do you know? Because in the field, actually what happens is like you go into the field, you are there, you sometimes you're just with the machine and it's only compacted, only compacting material, and you need to be aware what you are going to work with. Okay, so many times they leave the material one side of the road, and you know it can be warm. Here in South America we can have around 40-45 degrees and it starts drying. So how do you know the material is actually good to be compacted? So what you can do is you can make a ball of material in your hand, like a snowball, let's say, okay, but with material of the material you're going to compact. You are going to drop it from a height of 1.5 meters to already compacted place. So you can see here this part is already compacted, and when you compact it, it will hit the floor, and depending on the behavior of the material, you are going to decide, or you are going to see if the material is good to, it has the good content of water, or is still a bit dry. So, for example, if it breaks in several parts, it is spread around like several particles, then you know that the content of water is less than optimum. If you have it breaks in 2-3 parts that are fixed parts, I would say that it maintains some stability, then you can say, yeah, it's quite close to the optimum quantity or optimum moisture content. And if it deforms completely, it doesn't break, it deforms, like when you have mud that it hits and it just deforms, then you know it has too much water. So this is quite a quick way to know when you're in the field if the material is good or not. And even I was talking a few days ago with a customer that he has attended to these similar trainings here in Latin America. We did some similar workshops, and he called me like he had some issues in the compaction, and I requested him this kind of video, and we could see that it was quite too much water. So this is something that can help you even if you are not there right now due to the, you know, we are aware of the world or the global conditions we are, but you can see it from even in a video and be aware what's going on with the material. Okay, so this is quite an example of how you can handle, you can understand what they are compacting. So when you go in the field, almost above 80% of the problems are due to application problems, due to operation problems. So many times when something is happening with the machine, we miss this part. Most of the technical job we do is we go there to the field, we are supposed to change a component, we change the component and we go back. And we have to change this perspective to not only for us as Dynapack, but also for our customers, to offer a more complete way to help them, because this is a good opportunity to train the customer, to explain that what they can fix or improve in their operations. And of course the operator will learn a bit more. They are always eager to learn from us, so if we share information from them, they are going to be happy with the information they can get, and with every opportunity we can help them to improve. So we already seen that we can measure or we can handle somehow the quantity of water. Then we talk about the energy we are using to compact the material, and now we're going to talk about the machine we are going to choose. So we have vibratory compaction and we have tamping compaction. So depending on the machine you work with or the material you work with, you are going to select the machine you are going to work with. So you can choose between vibratory compaction or tamping compaction. I did not include static compaction here, but I will mention a few comments later on about what can we talk about static compaction. So general rules for application. What we have here, we have for coarse soil, we have a smooth cylinder, and when we are talking about cohesive soil, we are talking about tamping compaction. Actually, we can have also here a cylinder with pad shells to do the compaction. But when do we use in any of these or any of those machines? Well, when we're talking about clay compaction, due to the material that we have here, we need a lot of force, we need a lot of energy. So you actually use big machines to compact this kind of material. So we are talking about clay, we can talk about the CA 5500 PD or a CA 6500 PD. But actually you can have a better machine like the CT3000 for this kind of material. For this kind, I would actually recommend the CT3000 because of the high impact force. Okay. Then we have for lime compaction, this is a bigger grain, actually bigger size of particle. We can use smaller CA machines, not the big ones. Still, we can use the CT3000. This is actually a good machine also to compact lime. Then we can have gravel and sand, or the gravel, multi-graded gravel also, and sand compaction. And you have particles here, of course. And the bigger the particle you have, the bigger the machine. So you can gravel, this one you can do with a CA150, a CA15, or CA25, but even a CA2500. But the bigger the particles, you should go for a CA2800, CA3500. So you have to understand that not only because of the size of the machine or the weight you are going to compact, because also the cylinder, the thickness of the cylinder is going to be the one that is going to receive all the impact in the material. So you have to also check this one, because the bigger you go, the bigger you will need the cylinder. And for example, if you are talking about boulder compaction, here you are talking about 15 centimeters particles. Okay, these are rocks. These are not particles anymore. We're talking about rocks here. So if you want to compact there, you will need a bigger machine and a smooth cylinder also. Please do not use, we had this experience here with one customer that was using a pad shell in the cylinder to make like, to break the rocks. Actually, it could, but you're going to have a lot of wear, and the bouncing effect on the machine is going to be such, with such force that you're going to break very easily the shock absorbers, and you're going to damage the cylinder. You have to be aware what kind of material you are compacting. Otherwise, you are going to damage the machine, and you're going to increase your time of operation and also affect your productivity. So this part, we have to be aware where are we using the machine and why we are using this kind of machine. What parameters to consider for vibration compaction? And here we're going to go into more about operation tips. So, is a 15-ton better than 12-ton? One of the questions we usually receive from customers when they want to select the machine is like, I have this option, this one is more weight than yours, and they feel or they think that this machine can be better because it has more weight. But you have to understand which one is responsible of the job. So when you think about a smooth cylinder or even only a auto-propelled cylinder here with the machine, you have to think that the engine has the pumps, and the pump is sending flow to here to the vibration motor and move the eccentrics. So the one that it's actually making the job, or the compaction job, is the front module. In the front module is the responsible one. It doesn't matter how much weight you have in the whole machine. What is important is how much weight you have in front of here. So actually here you have to think about if it's 15 ton, we have a 12 ton machine, but here in the 15 you have, I don't know, 12 ton here, 3 ton here. And in our 12 machine, in 12 ton machine we have, if not mistaken, we have our almost 6 ton here and a bit less than 6 ton here. So actually this one is doing the job. So you have more weight, you have more strength here. Also you have to take in consideration the amplitude and the vibration frequency you are going to hit it. So this one is making the work. So if you have the values here, then you can compare. Doesn't matter if you have a 15, 14 ton machine. You cannot compare them in the operational mass. You have to compare them in the front module mass. Should I deactivate the vibration when in reverse during compaction? Well, no. Actually, when you make a pass, it's moving from point A to point B and then from point B to point A. You don't need to deactivate the vibration. You can just go forward, you reach your point B, you come backwards, and you don't need to deactivate the vibration. So there's no need to do so. Do I change the amplitude when I change the direction of compaction? No, you don't need to change the amplitude. Actually, what you can see in the field, the operators do not change the amplitude at all. They will change the amplitude only when they are not, when they need to do additional passes, and in high amplitude they cannot control the machine. So then they will go to low amplitude. Or when the machine is too old and the cylinder is already wear, the weight of the cylinder lowers, so the amplitude makes the cylinder a higher jump. So then they think, no, this is too much force, so they work with low amplitude there. So this is actually the difference you will find. Most of the time they will work in high amplitude, and then they will forget about what that lower amplitude exists. So one recommendation here, actually, if you are going to change of amplitude, you have to stop the vibration. You stop the machine, you stop vibration, and then you change amplitude and you start vibration again. Otherwise, this high energy, when you change from high to low or from low to high, can damage internally the eccentrics of the machine. So you have to take in consideration this part. And can I vary the speed? Actually, the machine goes up to 5 kilometers per hour, well, almost 5. But then again, the joystick, even though it's a potentiometer and you will move forward or move backwards and it can vary the speed, you shouldn't. You just go forward up to 5 kilometers per hour and backwards up to 5 kilometers per hour. Why is this? Because you have an amplitude and frequency already stated in the machine. So it will actually jump as many times, if not mistaken, is 33 times per second, and it will hit the material 33 times per second. If you go too slow, you might hit the same spot more than once, okay, or too many times actually. And the more you hit, you are going to reach faster, somehow faster your compaction degree you need. Maybe if you go too slow, you are over compacting the material, and maybe you are damaging the material, and not only the material but the machine itself. So you have to be aware of how fast you go. The material is designed, you go 5 kilometers per hour, then you go backwards. You can go lower, you can go slow to reach the compaction, but it doesn't mean you are going to reach the compaction faster. It actually means that maybe you are going to do it more slowly. Okay. Some technical information we can find actually in the web page. As I was saying before, it's the weight of the machine. You have here the operational mass, the operating mass, and also you can find the compaction data. Okay, but one value here is the centrifugal force. The centrifugal force you can calculate here. You have the formula here. Fortunately, our engineer department already work on this one, and they can provide us the value directly. But some people like to compare this value. You can have it here. You can find it in the web page, in dynapack.com. And of course, as I was mentioning before, the one responsible is the front module. So you need to know how much the front module weight, and then you need to understand that the width of the cylinder has a value, and if you divide the weight by the width of the cylinder, then you can find the static linear load. This one is also important. Of course, you can find here the normal amplitude you have in the machine, the vibration frequency, that it's times per second that the cylinder is going to hit the material. Also, you can find this information. Actually, you can have it, and if you don't have access to this, you can also ask us, Dynapack, or your distributor or your dealer, and they can share you this information. But we have to understand this information a bit. This is some theoretical information that we share. For example, we are having here the maximum recommended layer thickness of the material we can compact. So we can actually, with a CA 2500D, we can compact these different materials and up to this amount of thickness layer. But this is theoretical. You know, when you start using the machine, it will start wearing. Okay, you will lose when it comes in the time, you will lose thickness of the cylinder. That way the amplitude will change, or the impact force will change. Also, if you are not looking into the maintenance of the machine, you will have some leakage, and maybe this way you will lose some pressure, and this way you will affect the compaction of the machine. So actually, even though we can say this can be done by our machine, we have to take in consideration that this can be affected by the maintenance of the machine, by the wearing of the machine, and of course by the experience of the operator. Okay, so when we take, for an example, the gravel multi-graded, I can say that a bit more than 50 centimeters of material we can compact. That if we take it to how many passes do we need, then we have to analyze what is the degree of compaction we need. So for example, below here you have a low compaction level for modified Proctor, a medium compaction level or degree for modified Proctor, 95%, 98%, and then we can see here that thickness of the layer we can compact. So in 4 passes we may reach a low Proctor of 50 centimeters, but for a medium Proctor we will reach 32 centimeters maybe, no more. So for example, if we are going to, we need for I don't know, for soil compaction, when we're talking about road construction, but urban road construction, actually they are around 95%. So if we're working 95% and we need a 50 centimeters compaction of material, then we might need 10 passes. And once again, these 10 passes are theoretical. It doesn't mean that the machine will reach in 10 passes the compaction level. Maybe we're going to do it with 9, maybe we're going to do it with 11 passes. So we will later check on how many passes do we actually need when we are talking about compaction of material. But this is a nice start, because now you're aware of the average need of passes you might need. Then again, you will need to do some additional tests, so you are sure of how many passes you will need to compact the material. When we are talking about tamping compaction, we are talking about what does the compaction, what is responsible for compaction here in the machine. Well, in different to the CA, then we're talking about the weight of the front module and the amplitude and the frequency. Here we're talking about speed. So you can see here the engine, you can hear the reductor, and you can see here the axles. So the more speed you have, you are going to have more energy to impact or to compact the material. So what is the best compaction speed? what we have seen in the field, it's around 18 to 20 kilometers per hour. Miguel, but we have our competitors that they say that they can achieve 30 kilometers per hour. Of course, our machine can also go up to higher speed, but we have to understand something. The higher speed you go, the higher energy you create, and the higher force you will compact the material with. So what you can see is like the higher force you will find will create a more bouncing effect. The bouncing effect will impact the machine and will create vibration. So the higher speed you go, the higher vibration you will feel in the machine and in the cabin. So the operator is quite aware of how much energy they can feel. Okay, so when you are actually going faster, the machine vibrates too much, so the operator tends to go slower. So when you need to go slower, you actually have to think about it, how slow you have to go for the machine so you can control the machine. So when we're talking about our competitors, you can go 15 kilometers per hour, and that's the most you will reach. There are few of them. I think a couple of them are very well known, but they cannot go higher speed because the vibration is too much. So what we have, actually, we have some experience here. You can talk with our product specialist here in Brazil, Marcos Bueno. You can send an email here and ask him, because he's done some experiences in the field with this machine, and he has compacted, I think, even up to 24 kilometers per hour before the operator would actually say, yeah, there's too much vibration, I have to go slower. Okay, or I have to maintain this kind of a speed. So this is a good speed. Actually, this is an average speed you can find with the machine, but you have to be aware of other conditions of operation, of the quantity of material you're going to compact. And here we go again of the thickness layer we're going to compact. So according to the machine, if you are talking about silt, you can go up to 42 centimeters, and we're going to clay, we're going up to 30 centimeters. So one detail here that we actually missed before, to say before, when we were talking about compaction, usually you have this machine that moves all the material, and then you have this machine to level the material. So you will have a similar thickness layer through all the surface you are going to compact. But you may find some parts that you are not sure that it is 30 centimeters in average, or 20, or 50. You cannot measure that. Maybe some parts you will have 60 centimeters, and others you will have 40 or 30 or 25, 20, depending on the material, depending what is below. This part is very interesting, because if you miss this part, you can have some places more compacted than others, and this can affect actually what the readings you are going to have in whatever tool you're using to read the compaction. And here again, when we're talking about CT3000, and we're talking about, for example, clay, what I was talking about with Marcos, the experience we had was 25 centimeters. Okay, and maybe you say, Miguel, but to reach a high compaction, we're talking about 22 passes. This is too much. Come on, you are talking about higher speed here. We're talking about 20 kilometers per hour, so you can go higher, you can do it faster, you can do it in bigger, because the machine has a more width, so you can compact more area. So when you're talking about clay, that's why we usually recommend this kind of machine, so you can do it in a faster not only speed but time. We're talking about less time. One single machine to do the machine that can actually you can save more time here to do this kind of job. So now again, you have 22 passes, but this is a theoretical value. You can find, as I mentioned before, some areas with more material that you can use, you actually lose. You will need more time to compact. Then again, you need the experience of the operator, and of course, how is the machine maintained. If you are not using a good the maintenance schedule, you're not respecting the maintenance schedule, you can have some issues with the machine, any machine. So I've been talking about Proctor and compaction degree, 95% compaction, 98 compaction degree level. So what are we talking about here? So first we need to take a sample. Actually, when I was talking about compaction, I was talking about the Proctor test. What you actually do about after compaction, you will take one sample here. For example, with this core sample, you will take this one and then you will take up to the oven at 60 degrees. You will let it dry for a complete day, and next day you will measure the weight of this material and you will compare it with the material in the Proctor test. Actually, in the Proctor test, you do the same. You will add the quantity of water to the material, and then you are going to reach the highest density possible, and then you will have a mixture of water quantity plus material quantity. So you will dry the material, and then you know how much material you have, and then you weigh the material, and then you compare this weight. So first you take this sample, you take it to the oven, as I mentioned, you let it rest. You have also some tests in the field where they use some centrifugal force to separate the quantity of water, and then they will calculate, well, if I have this, I weigh the material, if I have this much weight of water, then the rest it's of material, and they do compare the values. So here you take the sample, then you know how much weight of dry material you have. You have the lab test, so you know how much in the Proctor test, how much is the maximum dry density, and then you are going to divide them. You have your dry material in the field, and you divide it by the dry value, and of course, if you multiply it by 100, you will have the compaction degree or the compaction level you have achieved with the material. Now, this is how you do it in the field, how do they compare it. But then again, this is the most common ways I can speak about, because this is what we usually see here in Latin American countries. But of course, you can also have technology, and when you have technology, you have to use technology. What is the recommended number of passes? When we're talking about recommended number of passes, we're talking about, first you have to know two values. What is the compaction degree the customer is looking for, and also what is the recommended number of passes by the manufacturer. So we as Dynapack, we can recommend a number of passes to reach a certain level of compaction, and of course we can also have the compaction degree the customer is looking for. So what we have to understand is how many passes do we need to get to that. So we have the thickness layer of material. We know about 10 passes to reach that material. So what we actually recommend is, if we need 10, let's start measuring from pass number 8. So from the eighth pass, we start measuring, and then we do the ninth pass, and then we say, yeah, we are very close, or we have reached a compaction degree, or no, we need a bit more. Then we do the 10th pass, and then there we are. Or maybe not, we need one more pass. So what we actually do is we take this, we start recording, or we have to register every value we reach with every pass, and then when we can take this to several locations, so that we are aware, we can get an average of passes that we need to reach a certain level of compaction, a certain compaction degree. Okay, so this is how we actually could do it. We could actually calculate the number of passes. But as I was mentioning before, if you have the technology, you should use the technology also. But this one is to understand how the technology measures this one. So, do we have another alternative to control the number of passes? Yes, of course, we have the compaction meter. It's very well known here in our region. And the compaction meter uses an accelerometer that actually it's kind of reading the bouncing effect in the machine. It will show in a display how much is the compaction. So when we reach a certain level, depending of the type of material we're compacting, it will show us, yeah, you have reached a compaction, or no, you still do the compaction until it show us how much it compacts. Another the possibility we are talking right now is a dianalyzer. But the main difference between compaction meter, dianalyzer, and the method I was showing before, this more manual method, I would say, is like the number of passes. When we're talking about number of passes in in this slide, we're talking one pass is from point A to point B and from point B to point A. That's one pass. Okay, when we are using the technology, here they are measuring each movement of the machine. So when you move from point A to point B, they are actually showing already what is the degree of compaction of the material. The same with the analyzer, it's already recording, and you will see it in the application there in the display or tablet you have with the software. You will see that it starts recording every single movement and how the compaction degree in each passes is increasing. So maybe you will need a compaction. Well, if you are talking about the most common number of passes, you will need 5 passes and a half. So it will maybe you can understand it like in the analyzer like 11 passes. Okay, because you're moving from A to B1, then B to A2, then you have to do 11 passes, while in the other compaction you are using 5 passes and a half. So that way you are this is how technology will help us improve, because with 5 passes and a half, I'm already reaching my compaction degree needed. I don't need any more. I don't need to complete the other additional B to A movement to complete the compaction degree. So that's something you have to be aware of. That's something that I was talking with here with the department in Sweden also, of how many, when we're talking about passes, what are we talking about? Okay, but this is the old way, and this is how the customer knows it. Because when I go to the field and I talk with the customer, when we are talking about one pass, we're talking from A to B and from B to A. So when we are introducing technology, we have to be aware of the knowledge they have, so we don't mix up what we're trying to get to the customer, what we're trying to make the customer understand. One of the most disliked terms by the customer is overcompaction. But what is overcompaction? What are we talking about when we're saying that you are overcompacting the material? Actually, this chart is coming from my first experience with compaction. It was not with a roller, it actually was with a rammer. But what I obtained from this experience was like, what happens with overcompaction? The main question was, what's the problem? Of course, the machine was breaking apart. The customer was saying that this, I don't know if you remember, the LT6004, this machine was breaking, everything was breaking, the bolts were breaking, the heads of the bolts were breaking, the nuts were falling, the engine was breaking, several fissures on the engine, even the hoist point was falling apart, and the customer was, this machine is not good, we have quality issues. So I was like, okay, what's the problem with the machine? What's wrong with the machine? First, what I asked them, what's the application of the machine? What they were doing, of course, was trench compaction. And then I asked, what's the material? Of course, this is multi-gravel material, multi-graded gravel material. And how many passes? 15 passes. So then we started from there. What I checked with previous information, that was for the thickness of material they were using, the rammer they were using, they need around 6 to 8 passes to reach from 90 to 95% of compaction degree. So actually you can see here that between 6 and 7 we were around 95%. And actually when I was talking with them, what are you compacting and what's the purpose of this compaction, we were talking about, this is for a park, this is for lawn. So if it's between 90 to 95%, it's good enough. So actually 90 was fine. So to reach to 90, what we did, I was thinking about, if 6 is the minimum I need for 95 or a bit more than 90, I will measure from the pass number 4. So from the 4th pass on, I start recording each of them, and you can see here that we started from around 86%, and then we move up to 90, and then to 94. And here the operator actually said, well, we have reached the operation degree needed. And I told him, wait, you said to us, you stated that you needed 15 passes to reach the compaction degree. So we are going to continue recording how much, what happens with the other passes. So with the seventh pass, we were already above 95%. With the 8th pass, were around 100. And then it started with an 9th pass, we were below 95%. So what happens here? You keep on heating the material and then you will lose compaction. The more you heat the material, you will get a higher stability, the higher density. But if you keep on heating the material, the stability will lose. It will reach the plastic point and it will break. So the material breaks again and it gets loosened. So you will lose compaction. And then again, you need more energy to compact it again. But as the material, there's happening two things at the same time. The material is getting dry because you need more time. And you, because of the energy you're using, maybe you are putting or pulling the water to the surface. So you will break it again and the material will lose stability and then you will compact it again, but it won't reach the same compaction degree again. So you are losing material stability. Then 15 passes, of course, you are between 90 to 94 to 95% of compaction degree, but you actually with 6 passes were fine. So all this excess of energy needed, and every time you reach this part, you are already overcompacting, so you are creating more bouncing effect into the machine. So all this excess of energy was damaging the machine. This can be also seen in our machines. So what makes the excess of passes, how can it affect our material? It actually can break, you will see the shock absorbers that break first. These are like the fuses in the mechanical side of the machine. So if this one breaks very fast, it could actually mean that you are wrong in the application. Of course, we can have sort of happen that we have a material issue here. Could happen. But most of the time, we're talking about the energy that these ones are receiving back. So they are the ones that receiving all this excess of energy. Besides the volts, besides the machine, the vibration increasing in the machine, these ones are the responsible ones to receive all this excess of energy. And of course, you can also damage the cylinder. Of course, you can see here below that they were compacted quite huge particles. These are huge rocks. Maybe they needed a bigger machine, but this excess of energy and the usage, the application they were making of it, it could harm the cylinder, it could deform the cylinder, it was wearing it very fast. So you have to be aware of the application they are working the machine with. You have to go and see it for yourself or request this kind of information from the customer so you can understand what is going on in the field. Actually, some of the customers, I don't know if we have some customers here in the event today. I think they were invited. But many times when you are the owner of the machine, you don't have this information. You can ask your operators or the one responsible on the field, please send me some information what's going on and which machine you are using it for or using for the compaction. And then you can compare, be aware what's going on in the field, and you can be aware what can be happening with your machine and how it's being affected and how is the wearing coming. As I was saying before, I think the cylinder is a wear part. Of course, it lasts quite a long time, but it's a wear part, and it can actually break very fast if you are not taking care of it at all. So what we have here is that when the cylinder reaches 30% wear, you have to check for possible fissures, crackings in the cylinder. You have to see if there's some damage, and please do not weld them. That's something I highly or strongly against it, because what I've seen in the field, like they usually see some fissures and they start welding it, and they say, no, I'm welding it and I'm using this anti-wear welding so it will last longer. But actually when you weld, you are increasing or crystallizing the material and then it will break faster. Actually, it won't break the weld. It won't, the wear in the weld will actually maintain but it can crack faster, or the fissure can increase faster. So you might think, no, it's a cylinder quality. No, it's not that. It's because you are welding on it. Another part, it's like when it reaches 50% of the wear, you should replace, or you must replace the cylinder. Afterwards, it's pointless to work with it. One point I actually mentioned before was when you reach, we're talking about the cylinders here, when you reach this kind of wear, you can see here, for example, 17.4 millimeters. Some customers say, no, I want to recover the weight, so I'm going to weld some plates inside, and then I'm going to recover the weight of the cylinder or of the drum, and I can continue the compaction. Well, what actually happens first is, when I was saying before, you are compacting in high compaction, and when does the operator stops? They actually do a stop when the machine vibration is too high, because the bouncing effect is too high in the machine that you cannot control that direction. Somehow the steering starts moving by itself. So I stop vibration. I move to low amplitude, and I continue because they told me to do 10 passes or 15 passes, so I will do as many passes they told me. Even though I, as an operator, I'm aware that machine already reached the compaction degree, they told me 10 passes, I continue. So, and that's something that we have to be aware of. So many times the operator knows that the material is already compacted, but as the one responsible mentioned him that he has to do 10 passes, they will continue, even in low amplitude. But when the cylinder is, or when the drum is with a lot of wear, what they actually also do is, as with you lose weight, the amplitude starts moving the cylinder too fast, with too much strength. It jumps too high. So what they actually think, no, I will change the compaction or the amplitude to low compaction, to low amplitude, so I can continue the compaction. Okay. Yes, you can do that, but it will not solve the issue that the cylinder is already wear, that you may have fissures, and that you're not using correctly the machine. So what they actually recommend, no, if you are going to actually try to do this of recovering the weight, you should use as reference the lowest thickness of material, and then you are going to reduce everything to the same thickness. So you reduce everything to 17.4, that is the smallest one, the lowest thickness we have, and then we are going to recover the weight of the cylinder. But what happens here, if you don't do it correctly, if you miss 1 millimeter difference in the positioning of the plates, if the weld material you use is more weight than in the other, more material, welding material on one side than the other, or a bit more grams in one side, more the other, the movement of the cylinder will be like this. It won't get stable, and in time you will have an extreme movement in the cylinder, and it will start breaking the shock absorbers. And I would say that from my experience when I've seen it with customers, and even promoting not to do this, the most they would work with was 1 month, and then they will call me again to fix it again or change the cylinder. Most of the time it's just change the cylinder. Okay, so that was soil compaction. Now we move into asphalt compaction. I think it took a bit long, so I will try to go faster here, or reduce the content of material. Okay, so in asphalt compaction, what we were talking about was, like, we have the machine that is going to move the material. Okay, we'll mix the material, then we're going to level the material, then we're going to compact the material. Here we have to select the machine according to our needs, of course, and then we are going to use this or spread this sort of glue at top of the material before using the paper. And here I will leave you with a video, so I can take some water, of how they should not do it, but they actually sometimes do it. He is very, very skilled, by the way. Yeah, so this is something you can actually see in some countries, not only in Latin American countries. Yeah, but this is not the way you should do it. And besides that, you can see well, he might be skilled, but besides that, you can see that, well, that hand in the left, by the way, was someone from Germany. This was my first paper commissioning. He joined me there to do some additional training to the customer, so we were amazed of the skills of this guy. Of course, you can have the correct machine here to spread it. And one point I wanted to mention here is that most of the time when you are working with this kind of machine, you usually leave the glue to stay there for, I don't know, some hours or maybe a day. But due to rain conditions or weather conditions, sometimes they just let it 1 hour to dry a bit and then they will start paving. Okay, so this can happen also. So we have to continue with the road construction. So now we are going to have our track with material, with the asphalt. And then we can have maybe the feeder. We actually recommend the feeder so the paver won't stop. You know, every time the paver stops, the screed will leave some marks in the material. So you should actually not use this kind of thing, of material. You should actually use this kind of machine to improve this paving process. And then you can also use a crawler paver or a wheel paver, depending on the application or the job you are going to do. Well, I would say the main difference here, just to mention, is the traction. Okay, you will have better traction when we are talking about crawler pavers. So I'm going to talk a bit about asphalt. And when we're talking about paving, what we actually have is we do with the soil, or we'll say with the smooth cylinder roller, the embankment, the sub base, and the base, and then we're talking about asphalt. So in the asphalt, we usually recommend 3 layers of asphalt. We have the base layer, we have the binder layer, and then we have the surface or wearing layer, or the top layer also. So this is the one you should actually are going to do the maintenance. So when you are milling the material, you should be milling this one only, but it can happen that you will have to mill everything, of course. And what's the expected lifetime of paved roads? When we're talking about the expected lifetime, it's like, for example, you have a high road. What's the theoretical information you have? The wearing course, the top layer, it's between 10 to 15 years. The binder course is 15 to 25 years. The base course 40 to 50, and the base or the foundation could be 50 to 99 years. So actually here, what you can think about is, well, it should last forever, actually, for a lifetime maybe. But here, 10 to 15 years, is this one actually happening? Is this actually true? Well, actually not. This is a very well-known picture. Maybe it's been used in several of our trainings, but this is something that you can actually find in the field. These big holes in the asphalt, maybe this is an exaggeration of this guy trying to fish in this pond in the asphalt, but you can actually find some of these examples in some of our high roads. So we have to be aware not to do this, but how do we improve this? Okay, so we have the foundation, and the foundation is well known because you do this with the smooth cylinder roller. You will compact the material, and then you can improve with the paver the difference in the height or the surface finish you are going to do. So if you do a pass, the first pass or the base layer could already, if you are using a good reference of leveling for the automatic leveling, you could improve this from 10 centimeters difference to 1 centimeter. And then again, if you do the second layer and you work with a 4 centimeters layer, you could improve up to a difference of 2 millimeters. And then you are going to do the top layer, and then you can reduce it up to 0.4 millimeters. So this one can be controlled, or this one could be actually improved if you are using control of the height. So they will minimize this by layer. So every layer you do, you will improve the material. So actually, something we have seen in the field is the customer actually they want to do 2 layers done, or as I have seen in some Latin American countries, is like they have to do some 10 centimeters of asphalt, so they just do 10 centimeters, and that's all. That's all they will do from the beginning to the end, and sometimes they don't even want to use the automatic leveling system because the audit people that is in charge of checking how much of the compaction degree you're achieving, they are looking all the time for 10 centimeters. So we actually recommend that this kind of information should be not only for our dealers or our customers, we should look into all the people that is involved in the paving process. So they may understand that sometimes you will find a bit more material or a bit less material, because if you are not using the automatic leveling system, you are just copying what you have below. So if the foundation has a lot of waves, you are just doing more waving, and then you will have some complaints about this because now the surface have too many bumps. It can be actually because you are not using the auto leveling system. We remember that when we were talking about compaction, we had water, air, and soil particles. But here, when we are talking about asphalt compaction, we are changing the water by a binder. So this one is going to act like lubrication and glue of the materials. So when you are compacting, you are accommodating the particles, and the binder is filling the gaps as well as the air. So the quantity of binder is going to be the important one in this kind of compaction. So what should be, or what properties should the asphalt have? We are talking about stability. We need the material to be stable. We need, the higher the load, the higher the force you are going to do. So we need a stable material. So we need it to be flexible because, as I was mentioning, higher load, it will deform. But if it's going to deform, it actually have a permanent deformation resistance. So if it deforms, it should somehow recover from this deformation. Durability, as I was showing before, it's expected to the lifetime for it should be around 10 years or more. Enough gaps to avoid bleeding. If you use too much filler material when you make the asphalt, or too much binder, you won't have enough space. So when you start compacting the material, the binder will move atop. Well, here below you can see some marks of water actually. But you could even find, if you are not using a correct quantity of binder or material, the binder could move atop the material in the surface, and you could see black because of the binder. It's black. You could see some black marks here, and you can actually it will going to be slippery. And if you are talking about slippery, you should avoid the slip resistance because you are looking for traction. You are not looking for a slippery surface. You are looking for traction. You can some friction, so you can actually gain speed, and also so the wheels or the tires can somehow stuck to the asphalt, and you can turn at high speed when you're driving at high speeds. Unworkable because depending on the surface you are working, if you are in a parking lot, if you are in a race track, or you are in a high road, in the mountains, actually, you can have different sort of conditions. So it should be workable. You should be able to move the material or work with the material. How is the composition of the asphalt defined? Well, the asphalt is an aggregate mix, so you will have different size of particles here. Actually, the biggest particle, that's some concept we usually should use, is if you are going to use a 5 centimeters thickness of material, we should be able to have 3 stones above each of them. So we are using 1 particle above each. So if we have 1, 2, and 3, then these are these 3 should enter in the thickness. So if we're talking about 5 centimeters, we can have 16 millimeters particles. Of course, you can have bigger thickness or more thick material, layer of material, then you can have bigger particles. You have a smaller thickness of layer, you can have smaller particles. Then you can have these are aggregates, and you can have the fillers, the finer grain material. These ones have to be controlled depending of the material you're going to use. And of course, then you are going to use the binder. And you are going to define this quantity of binder. So how do you define it? You do it through the Marshall method. As we had the Proctor method, we are having the Marshall method. That is the same. We are going to create some energy with using a weight and let it fall from certain height. And we are going to heat the material. And actually the first one is 30 impacts on both sides. So if we are compacting the material, we are going to gain a sample here. You can see a sample. And we are going to impact it around 30 times. But if you are using bigger particles here, for example, for the binder cores or the base cores that you use, you have more thickness of material, you can use bigger particles. So the bigger the particle, the bigger or the more quantity of heats you are going to use. Then again, this was modified also later due to like we have the similar Proctor the modified Proctor we are modifying here because of the load the machine is using. So at the beginning they may have used 30, but in the end we have to create more layers of asphalt and bigger particles below to maintain more load of material. What do they do in the Marshall test? What they actually do is when they have compacted the material, then they will place in the machine in this position, for example. And then they are going to press it. And as you can see, the more you press, there's one point where it's going to break. You can see the fissure there. It happens with the material. So what happens is you are going to increase the load, and when it breaks, then you have measured the maximum load the asphalt can sustain. And also, this difference between the normal form of the material and when it deformed to this oval, this movement or this displacement is known as the flow. So, actually, you are going to have some values here. You are going to talk about the density, how much the optimum content of binder we will find, the higher density we will get. Also, air voids will be measured against the binder content, and we will have the stability by the binder content and also the flow by the binder content. But these three here, okay, that we have the stability, the maximum load, we have the density, and then we have the binder content. These three can be measured and divided by 3, and then we have the optimum binder content that actually it's almost always around 6%. Okay, so actually when you want to calculate the this one, you use as a reference 6%. So this one is it's not one, but of course we are going to use it as a reference later on when we are going to talk about compaction degree. But one point to mention here is like here, how do you weight this one? What is going to do this one? This one is going to be also weighted, and you are going to weight it in water, suspended in water. You are going to weight it wet, and you are going to weight it dry. So then you will, with these values, you are going to get the specific gravity weight of the material, and then you will go and compare it to the material you have compacted, the asphalt you have compacted. So in the asphalt paving process, we have to understand that the first one is the material that you are having in the asphalt mix in the asphalt plant. So here you can find material composition, material temperature, material segregation. This can happen. This can happen from the beginning, from the plant. And from here you can have around 160 degrees Celsius of material. Then you are moving into the transportation. You can also have segregation of material here, the smaller particles moving to the lower part of the truck. And then you have material temperature. It should be around 160, and it should arrive around 140 to the paper. And this will also depend on the distance of the construction place and time. It means how far it's the plant from the paver or the paving location. Then you have the asphalt paving. You can have the paving thickness here, the paving width, the quantity of material. You can also have material segregation here depending of the wear parts condition. Tomorrow we're having another workshop where we are going to check on these wearing parts. Material temperature. Once again, you should be paving around 140. I would recommend no lower than 120 because behind this one you're having the rollers. Okay, and then you have the tamper, the vibration you are using in the script. Then you have the job site condition, if the subbase was well done, and weather condition, if it's raining, snowing, I don't know, if the conditions are not good, then you may have problems while paving. And then the compaction, of course, you are going to, depending of the type of roller you're going to use, if you're going to use a double drum roller or if you're going to use pneumatic roller. Operating weight, the amplitude, the frequency of them, the number of passes, it's quite different here, I'm going to show later, and the speed of the roller. And here the compaction actually should be done no lower than 100 or 90 degrees maybe, because for example here, if it's too cold, the material, and you start paving, even with the discrete, you can find that it starts breaking the particles. So if it's too cold, you will find like black marks in the asphalt, or maybe it hits too hard because you have too much tamper and vibration, and it starts breaking the particles, so you will find some white marks in the asphalt. But if not there and it's too cold, you will find it while compaction. You will find it, the vibration and the impact will start breaking the particles, and you will find some white marks in the asphalt. So who is the first responsible of the asphalt compaction? Well, actually it's the paver. So when we are talking about paving, the first, or when we're talking about the soil, the road construction, you have the soil compaction, you are talking about the rollers, and then you move into the asphalt compaction. When you're talking about paving, you start with the paver. Behind the paver you will find the rollers, but the first one is the paver. And in the paver, which one is the responsible of compaction? Well, it's the screed. So depending of the head of material and the thickness layer, you will make this one work, and you will have the tamper, and you will have the vibration of the screed, and you will gain a pre-compaction degree of material. So depending of the pre-compaction degree of material, you will have the number of passes you are going to use with the roller. So depending of the script you have, you will have different pre-compaction degrees. So even if you have 60 to 70, 88, for example, this is the most well-known, the tamper vibration scripts. Now we are with the tamper or the high compaction with a script. You can actually reach up to 96% of pre-compaction, but these are theoretical values. It highly depends on the wearing of the parts or the maintenance of the script, or even if you use tamper or vibration. If you're not using, because I've been in the field, and when I'm looking, no, I'm not using tamper. Why? I don't need it to. I don't understand why, because I asked the question to operator, they don't use it. They sometimes forget to use the vibration. And of course, this will affect the compaction or the number of passes you will need with the rollers, and even the compaction you will do in the asphalt. So once again, if the wear parts, if you have wear parts worn, you will find something like this. This is a quite example. Tomorrow you will have more information in the workshop that Gert is going to work. Gert is going to make about these wear parts. But here the one responsible, as I was saying in the script, is the tamper. So when the tamper is wear, you are having no compaction here. For example, you can see here from below that you have all this contact area that is responsible for the compaction, and here you can see that you have no contact area, so this one is doing no compaction at all. Okay, And actually, when you are talking about the screed, you can also talking about the screed plate. Actually, the screed plate wearing is also affecting the compaction. So you have to be aware of the wearing level in the machine. And this one is, when we're usually talking about compaction, we tend to forget about the paver. But this one is the first responsible when we are talking about asphalt compaction. So you have to start thinking about first of paver. And then you can start thinking about the rollers. Here is the first comment I would like to add. Usually you can see in the field that sometimes they start with a double drum or they start with the pneumatic rollers. But which one is the first? What the recommended way to do this is first the double drum roller. But why? Because it has vibration. What happens here? If you have two particles, for example, I will use these two pieces. You have one above the other. And they are like this. If you use only the weight of the material, they are going to press against each other. They are not going to reduce that much. They are not going to accommodate. If you use vibration, this particle may fall and accommodate atop this one, and then you will increase the density. So when we are talking about vibration, it will reaccommodate the particles, and then you are going to, using the frequency and the amplitude, you will have better vibration or better compaction, and then you can completely seal the surface of the asphalt with the pneumatic rollers. So that's what actually why we recommend the way we use. But what we have seen in the field sometimes is that they usually go first with this one. I would say that this is quite common here in some Latin American countries, and then they go with this one, and then again with this one, or in the end they will go with this one but no vibration, just to remove the marks of the pneumatics here. Okay, but actually I have not find a quite some difference between the finished compacted asphalt, but what we actually understand, what we actually recommend is this one first, because it will reaccommodate the particles. So here we're going to talk about the effect of the compaction time. So we're talking about vibratory compaction and static omniting compaction. When we're talking about vibration compaction, we're talking about who is responsible. In this one, you know, we have vibration here. So we have similar questions here. Should I deactivate the vibration? No, you don't need to deactivate the vibration. You go forward and backwards and it will vibrate. But actually, what is ABC? Because this machine usually have ABC, that's automatic vibration control. So when you reach more than 1.5 kilometers per hour, the machine will start vibrating, and when you will go lower than 1.5 kilometers per hour, it will stop vibrating. Okay? So then, should I change the amplitude when I change the compaction direction? Depending on the machine, you will or will not have different amplitudes. Okay, the small machine, some of them only have one amplitude and on. But do you have to change the amplitude? No, you don't have to change the amplitude again. And they won't change the amplitude. They will remain in high amplitude all the time. Can I vary the speed? It's similar to what I was explaining with the machine before. If you go to 5 kilometers per hour and you go back to backwards 5 kilometers per hour, you don't need to change the speed. Actually, you can, as I was saying, you go slower, you will have more impacts in one location. And you are talking about here with this kind of machines above 60 hertz. So you will have more hits per second in the same spot. So actually it does not help to go that slow. Some technical data you will find, of course, in our webpage is the total operating mass, and you can find here also the mass, the module mass. Front and rear are the same. Okay, and then you can have some compaction values. Once again, centrifugal force is already calculated by our engineering team, so no need to go deep into the formula. And then you need to know the weight of the front and rear module. It's here only in the front module, but you understand. And then you can do the same. You have the width of the cylinder, and you divide the weight of the module by the cylinder, and you have the static linear load. You also will show, they will show the nominal amplitude, high and low, and the vibration frequency. Then again, you can find also information about the compaction information. What's the asphalt compaction and asphalt compaction details, but this is different here. You don't see the number of passes. But why? Because as I mentioned before, it highly depends on the pre-compaction degree you can reach with the paver. So if you reach 88 compaction degree with a normal tamper vibration paver, and you need to reach 100% compaction degree with asphalt because this is a high road, then maybe you need 2-3 passes more, depending of the size of the material. But if the wearing parts of the paver is not using a correct tamper revolutions or vibration revolutions, I'm talking about the motors that activate both of them, then you won't reach this 88 pre-compaction degree. So these values will change actually the number of passes you are going to do with the machine. So here what they can tell you is if you are going to do 2 additional passes, what I can do per hour is like 3,500 square meters per hour. And if you are going to do 10 passes, because you have to thickness layer or the thickness of the layer is higher, or because you are not doing no pre-compaction at all, like in some American pavers that they only have, maybe they have vibration, sometimes they don't even have vibration, they only spread the material, they don't pave, then you will need more passes. So that way you will need to do more passes and you will need more, you will not do as many square meters per hour. And the same thing you can talk about capacity, because you can measure it by tons per hour, and it will also depend on the thickness of the material and the number of passes you will need. So you can actually check for this information. And of course, here's one question I want to mention. Can I compact gravel with a CC? Yes, you can, but the difference is the thickness of material you can do and the wearing you will cause in the CC is higher, where of course you have to understand that the CA, for example, 2500 or a CA25 has the thickness of the cylinder is 25 millimeters, while in the CC you have 18 millimeters. So you are wearing faster the CC, and the depth that you can compact is smaller. So actually it can do it, but it's not like you should do it with it. You can do it, but it's recommended for asphalt. Now, what we're talking here, and actually don't understand why it appears always first, but anyway. When we're talking about static or needing compaction, we're talking about who is responsible of the compaction here. It's the weight of the machine. Okay, so the weight, for example, you have here a CP 1200, and the weight of the machine, you are having some metal pieces here that you add to gain more weight. And this is going to be the total weight of the machine is going to be divided by the number of wheels you have here. So the number of wheels you have here will affect how much weight. You will divide the weight of them by each wheel, and you will have the compaction force per wheel. So the one responsible here is the weight of the machine. Okay, so what is the best compaction speed? Actually, the machine can reach around 8 kilometers per hour. I think it can be a bit higher, but it depends on the surface. If you are in a slope or anything, this is around the speed. But once again, you should go forward maximum, backwards maximum. When you are in work mode, you won't go up to the highest velocity possible. You will go up to the highest the velocity the machine should compact. One question that I want to share here is, what is the best way to clean the tires? Actually, what you have here is like, you can see here in the video below, or in the right, is that there's no operator. The machine is moving by itself. Why? Because what usually can see in some countries is that they use diesel to clean the tires. So when they clean the tires, you have to spread the diesel in the tires so that the asphalt won't get glued or fixed to the, you can see the operator now. And what he's doing is just using some diesel to clean the tire. And now it's going up the machine and he's moving reverse. Okay, we have alternatives like Dynaguard, okay, or even in the market you can find a glycerin-based material that can help to avoid that the material will stick to the tire, and then you don't need to do something like this. First, here you are going very slow with the machine. As I was saying, you don't need to go that slow. Second and most important, I think the most important part, this is a safety issue. He shouldn't be doing that. Okay, he's crazy. But of course, this is something that can happen in the field. This was shared by one of our dealers. And of course, this is not a brand issue, this is an operator issue. And then again, that was I was saying before. You can find many times of operators and they can say maybe they have 10 or 15 years of experience, but it doesn't mean that they have 10 or 15 years of good experience. They can improve, and we are in charge of making them improve. And these kind of workshops are also available for our customers, so we can share this kind of information and help them improve their operations and their safety issues. Talking about here, for example, same as you see, if we can use this machine in gravel or in compaction of multi-graded material, yes, we can. But once again, this won't affect the same way the material. This won't vibrate, they won't reach the same compaction, you won't get the same thickness of layer that you can compact. You have some information shown there in the web page. You can check if you need it. But actually, the most common way of use this one is for asphalt. Here you have some compaction information, and of course, as I was saying, if you have the paver compacting first, it will affect how many passes you need with the double drum roller, and of course, how many passes you will do with the pneumatic roller. What about a combi roller? Because we also have these small machines. And which one is responsible for compaction? Well, you have both. You have here vibration, and you will have static or kneading compaction. So actually this one goes first and this one goes later. But the mixture of them lets the work or the job done. Should I deactivate the vibration when moving in reverse or during compaction? No, you don't need to deactivate the vibration when moving in reverse during compaction. We already explained that. Why? Does it come with ABC? Yes. Can I vary the speed? Once again, the speed should be 1. We shouldn't vary that much the speed. It's going to affect how much impact we are doing into the material. Maybe we are going to over compact the material. Some technical data about this machine I thought was important to share. We have here again with centrifugal force, and we have the module weight in the front and in the rear. And of course, if we have the front, we can compare it against the width of the cylinder, and if we divide it, we are going to have the static linear load. And in case we use the rear weight and we divide it by the number of wheels we have, we are going to have the wheel load. Okay. In compaction degree, what we're talking about, what is the specific gravity of the compact asphalt? Here we will take a sample. We will use a core drill. We will take the sample, then they will take it to the lab. They are going to weight it dry, weight it wet, weight it suspended in water. Then they will get the specific gravity weight of this material, and they will compare it with the weight we received on the Marshall method. And then dividing both values, then we are going to have a compaction degree. A similar way we have with Proctor method, correct? We're talking about soil compaction. This is the way we're going to do. Also, you can have this one that is going to read directly from the asphalt. Okay. What is recommended for number of passes? I think I've mentioned this several times, but what is the compaction degree needed for the project? Depending, it's a road, urban road, if it's a high road, if this is an airport, you are going to have different number of passes. So, what is a number of passes? You have to make field tests, and you have to measure the pavers. How much was the degree of compaction you reach or you obtained with the paver, and then how much compaction degree you reach with each of the passes. So then again you will find how much you need to do. Okay, and each should be measured and registered. So then if you make 2-3 lab tests, then you are aware that what is the average number of passes you will need. Well, actually, that was once again 1.5 hours I did for this training. Now I'm going to move to the questions and answers section. I'm going to be there with Murilo, so we are going to answer for your comments or questions that you may have left in the chat. Give me 1 second here. Okay. So Murilo, now we are looking into the now let me check on it. Yeah, the number of passes. Yeah, 1 second, and my mouth is dry. Yeah, that's an issue of talking for 1 hour and a half. But let's see. Number of passes, yes. What actually we've been working for several years with our customers is that when we use from point A from point B and from point B from point A, that's 1 pass, and it actually should be vibrating. But if you are talking about static compaction, then you are not vibrating. You will measure it still with 1 pass, but not vibrating. So we measure 1 pass when we are talking with CA, for example, that has vibratory compaction. You have to measure it while vibrating, not while moving, because it will affect somehow, because you are using the weight of the machine to compact the material somehow, but it won't reach the level of compaction you need. The one responsible of doing the job is the cylinder, so you have to measure it while vibrating. While you are talking about a CP roller or I don't remember this one, CS14 or 1400, that's a static roller, okay, with smooth cylinders. You will have this, you are not vibrating, so you will move the pass from AB to BA. Okay, that's 1 pass. I don't know if you have any more questions or comments. Murilo, do you have to add anything here for the presentation, what I've been showing? Anything to share?
I believe only 1 point, Miguel. Regarding the machine speed.
Yeah.
One important thing to talk is about the speed, because the most important thing is maintaining the speed constantly. Because if you have different speed during the process, what occurs, different compaction degrees, then we can move the machine like 1 CP around 5 kilometers per hour, but the important thing is manage the speed constantly during all the process.
Yeah, that's something important we should always consider about the number, well, the speed. It should be constant, of course. Now completing, yeah, when we go to from A to B, that will be half a pass. And of course, I'm talking this from the knowledge we have shared before. Okay, we're talking. You cannot hear Murilo. Okay, now you will hear Murilo. I made a mistake. Sorry, it was my fault.
Thank you,
Okay.
Miguel.
No, I just fixed it. Okay. Yeah, something is like when we're talking about this concept, this is the old age concept. I don't know if old age because we are still using it, But when you point from VA, that's one pass, so from A to B will be half a pass. But take in consideration what I mentioned before, when we're talking about the compaction meter and when we're talking about the analyzer, then every movement you make with a roller, you are compacting. So it's measuring every movement. So it doesn't matter there if you are talking about half a pass, one pass. If you move from point A to point B, you have one compaction degree. From point B from A, you have another compaction degree. So when you are using technology, it somehow differs from what we are talking about when the most common way of measuring in the field. Okay, if you don't have compaction meter or you don't have the analyzer, you have to understand that one pass is from AB to BA. That's one pass. If we are talking about compaction meter of the analyzer, you will read in the display or in the analyzer, in the complete tablet, you are recording every single movement you make. So that's quite different concept. So you have to be aware of that. Please, Murillo, now could you explain again the part, most important part, about the concept of speed? Murillo, you there?
Yeah, sorry. I was checking our question here. Oh, about the speed, machine speed. What I thought is there is one correct speed, as told Miguel, but the important thing is always managing the speed constantly, because you have a different if you have a different speed during the process, what occurs one compaction degree is different in each point. Then the most important thing is managing the speed constantly during all process.
Yeah, of course. Yeah, I do agree with you. That's something I missed there, and it's very important. We have to consider that the constant speed in all the process. We have another question here. Why is the compaction capacity specified in
Meters.
Okay, yeah, or square meter tons per hour? Yeah, we're talking about here about volume. Of course, we are talking about volume of the machine, what they can actually compact per hour, what they can compact per hour. Depending on the thickness of the material, you have volume. You have the distance, the width, and the thickness. You will have volume. So that's why you can understand how many tons per or meters you can compact per hour. While whereas we're talking about the asphalt compaction is tons, because you will have I don't know, also an 16-ton truck that have left the material, and then you are going to compact it. And it also is measured in square meters per hour, and it actually depends once again of the quantity of material you are or the quantity of pre-compaction you have a shift with the paver, and then how many you can compact or how many passes you're going to do with the roller. Of course, it depends more in the quantity of tons you can have in the truck. And in the field, when you're talking about soil compaction, you have a lot of space. Yeah, if compaction meter, I was explaining before. When you don't have the compaction meter, or you don't have the analyzer, you go into, this is the digital area. Let's say compaction meter, it's one step before the completely digital area. Now the analyzer is fully digital era, but we're talking about analog era when we're talking about doing it manually, when we have to check off the number of passes here. Then again, when you have the number of passes, you have to measure. For example, I need 10 passes. When I reach the 8th pass, I'm going to measure the compaction degree with with a core drill, and I'm going to take a sample. or with this the cone test to take the sample, or I'm going to use a nuclear device to measure the level of compaction. Okay, so you can measure with several tools, and then you can compare the samples you take from the material also with the proctor or with the lab test you already have to get this dry value of the material, and then you will measure, or you will have the difference of the compacted material, whereas what the value you have in the lab with the value you have obtained in the field. So that's the way you will have to measure the compaction level. Okay, that's the best way to do. I don't know if you have something to add there, Murilo. Maybe I'm missing something. And please do leave your questions there in the chat box.
I believe that we don't have more questions right now.
Yeah, so far no more questions.
Yeah.
But yeah, that's something about the level of compaction. What I was showing in the presentation was we have the analog way and we have the digital way. And the analog way, even with the digital way, you will have something shown in the screen, or you will get some values in your USB, then you take it to your computer. But even though you do that, always the customer will use these devices, be it the core drill or the nuclear device, and they will measure and they will take it to the lab and compare what's the actual compaction degree you have achieved in the field versus the value you have obtained in the lab. So one question I wanted to take from the previous presentation that was about the pneumatic rollers. Why do they have vibration? One point I missed to mention there, besides this static vibration, is even if we add vibration to the pneumatics are made of rubber, so that rubber will somehow absorb the vibration force you could create. So imagine that how will you won't actually get any vibration energy from the machine, so it won't compact at all. So that's why you don't use vibration with rubber. You don't mix them. Okay, about the edge presser and the edge cutter, is cutter used initially and presser later, or vice versa? Actually, you will cut easier when not pressed before. And also, what I've seen, because some of our dealers or customers use the presser first, because they say, no, when I use the cutter first, it can leave a rough surface and the material will spread. And when I've used the presser first, then I could take some like tacks of material, pieces of material, not loosened material. So actually, it could happen like that. But what we usually find in the field is that they usually use the cutter first, because it will be easier for the cutter to cut the material. Okay. Okay, advantages of oscillatory drums over normally vibratory rollers. Well, this one is for more concrete applications. Okay, when we are talking with concrete, due to the material you have, you should use an oscillatory drum. You can actually use also the vibratory rollers, but you will use lower frequency, lower amplitude. Maybe you are not even using the vibration at all. You are just passing, because you make, for example, a bridge of concrete, and then you are going to do a layer of asphalt. So if it's a big construction, too much vibration, you can actually affect the concrete. While we are talking oscillatory vibration, you will have less energy in one point, so you spread the energy in the surface, and you can use oscillatory drums. Actually, I didn't include that one because we have this CC 4200O made in the US that is oscillatory oscillatory drum, and actually can make that kind of job. Okay, but actually that's different. The main difference in application. If you are talking about soil or high road, it's in the soil where we're talking a road construction with soil below. You can you have no you have better. I would say we have achieved better compaction or finish product with the vibratory rollers than with the oscillatory drums. You take less passes, I would say. That's mainly the main difference in application that I can find among them. Okay, so of course, if I will try to get more information, you can send me an email. I can share more examples, some pictures maybe of what I have seen in the field with these kind of machines. Something else I remember from and here's something that I can mention when we're talking about vibratory rollers. We have this CA 150A, okay, that actually when you have the A at the end is because it can be used in asphalt. And something I did not mention before was like this one has smooth tires, so it won't get stuck with the asphalt and everything, so it can work. But what we have seen is that some customers say, oh, so it's a CA, so we can we can change the tires for smooth tires and that's all. No, you have a water tank atop the cylinder. Then we add our water tank and then done. No, because the amplitude and the thickness of the amplitude of the cylinder is different. You have a smaller amplitude for this kind of application. If you go with a normal CA, you just change the tires and add the water tank, you can actually maybe destroy the material. So you have to be aware of that, because I've seen those chimeras around here, these monsters working in some of our countries, and the customers like it, but they can actually damage the machine. What is the difference between tamping compactor and pad-footed compactor? Yeah, but actually here what we have is CA with tamp. Sorry, Murilo?
No, the difference between CA and CT.
Yeah,
I believe that.
actually maybe it's like you have the CA PD with vibration. Okay, you have amplitude. You will have
Frequency.
amplitude, frequency there. Okay, while in tamping is only speed of the machine, and it will hit with the impact force created by the speed. Of course, when you are talking about this, because you usually use the CT or the tamping machine for a smaller thickness material and smaller grains. So when the material is clay or lime, or silt, I would say, lime or silt, actually silt. It's very small grains, very, very small. So you can do it better with a tamping machine. You don't need that much energy to reach, because, for example, for clay and silt, you will need a big CA 6500 PD to reach the same compaction degree that you are reaching with the CT. That I would say is the main difference. I don't know if you have something to add there, Murilo.
No, is it?
And taking that question in consideration, I didn't mention something. When you are talking about a smooth cylinder and you wanted to convert it to a pad shed cylinder, you use this pad shell kit. Okay, so you add the pad shell, the external kit, and then you have two things to consider. You are adding weight to the cylinder. So when you add weight to the cylinder and you have the eccentrics, they are made to make the cylinder jump for a certain amplitude. So if you are adding weight, even though you have the same eccentric, you are not going to have the same energy to make it jump the same height. So it will jump lower. So you have less compaction energy. So that's something I've seen a lot that they want to use. No, I want one machine. I want to use the pad shell kit whenever I want. Okay, you can do it, but you will have less energy. So that will mean lots of passes more needed to reach the compaction degree you want to achieve. Uh, let's see here. We have another one. Oscillatory vibrations are used in rear drums standard CC rollers. Offset rollers are not the gift list of oscillatory yet. Is there any scope or need of oscillatory in offset machines? Well, this is more like a market need. This one I would actually, I do not see this one because this is more a market need. I think the marketing team would be more knowledgeable about if they are going to consider it, if they are not going to need this one in the offset machines. I cannot share this one right now. I cannot answer this one, but I will check with them. Please do send me an email so I can take it to them and we can see what kind of information they can share with us about this one. Okay? Sorry, I couldn't answer that one, but I have not all the information. Yeah, as I was saying, that one, the pad shell kit, that's something we usually see here around in Latin American countries. That customers want to use them. Once again, the pad shells are not made to break rocks. Actually, they can break rocks, but that's not the main purpose of it. So you shouldn't use it like that. The effect you are having on the machine, it's quite it's damaging. It's hazardous for the machine. So you have to be careful there. Actually, Murillo had the experience to be on the field and see how you have a PD machine used for a wrong application and a smooth cylinder for the wrong application again. So these kind of application issues are 80-90% of the problems we have in the field, and we have to be aware of them. I don't know, Murillo, you have something else to add to what we've been talking here?
No, Miguel, I believe that is it. What about the use of the shoot pads? When you use this option, you lose around 35% of compaction force. Then it's very important to talk about it.
Yeah, as I was saying, you will have more weight, and as Murillo says, you
Yeah.
lose 30 to 35% of the compaction energy you have to do the compaction. So you will need more passes to reach what you. And actually, it also changes the depth of the compaction, because it doesn't. When you have the normal amplitude, you will reach, let's say, 50 centimeters of thickness of layer material compaction. But when you are adding more weight, it won't jump as high as before. So the energy, you lose energy, so you will compact less thickness also of material. So you have to be aware of that. Well, I don't know if you have more questions here. Let's give them some time. Well, we have some people here listening to us, so let's hope we can share more information with them. If you have any information or any doubts, you can send me an email. I will try to provide you as much information as possible. Please do join our YouTube channel here. We are sharing some information. You will find there also this presentation. Again, it will stay there, so you can check it again if needed. We are having two workshops. Like one is for the wearing parts of pavers tomorrow, how to optimize the machine, and the wear parts also. And on the next day, we're going to do training about bits, milling bits. Okay, so please do join the presentation. We have information that we really like to share with you. what do we have here? Is safe machines can the operator completely depend on the technology? You cannot always be fully dependent of technology. You will always have to be well, operator. One thing with operator is that we have this experience before with Dynap Compaction Optimizer. That was the oldest, well, quite old version of. It was the predecessor of the Seismic version. Seismic, I really do like it a lot. But what can happen with the operator is the operator is usually accustomed to stop vibrating when the machine, when they feel too much vibration in the machine. When the steering, it starts like moving left or right. It's not maintaining going to the front. It steers a bit to the left or a bit to the right. The operator say no, I should stop vibrating, or they move to low vibration or low amplitude. So what happens when you are talking about seismic or DCO vibration? It will change, the seismic will change the frequency, and while changing the frequency, it will change the amplitude. So what happens there? You won't feel that much vibration. So we have to make the operator aware of this. We have to train them so they will feel like less vibration in the machine. So it's not like the machine is losing power or there's something wrong with the machine. Seismic is controlling the how much frequency and of course how much amplitude you are going to compact with. So if we don't do the proper training to the operator, they will feel no, there's something wrong with the machine, and they will turn off the seismic and turn on normal vibration. And while this could let them operate, you could actually damage the machine. You could actually damage because you are going back into full vibration mode and you are going full high amplitude, and the bouncing effect will start damaging the machine and could damage some other components that are important even for seismic. So you have to be aware of this one. So you can be dependable of the technology. Yes, you can be dependable of the technology, but you cannot be fully dependable. You have to always compare it with the, even though if you can find it that it's so vibrating, you look into it with the, you will always make your core drilling or your compaction degree test to know how much compaction degree you achieved. So once you do this, the operator will be sure, or you will create the knowledge to the operator that yeah, if you use seismic, you will reach the compaction when it says compaction done. Actually, it will show you like you have achieved the compaction. So then the operator can be completely dependable on the technology. If you are not, if you don't do this experiment first with the operator, I'm sure they will turn off seismic and will go fully into manual vibration. So you have to do this experience first with the operator. So that just do the seismic, then do the compaction lab test. You show them that they are achieving the compaction degree, and then they can depend on the technology. Before that, if you don't do that experience with the operator, they are going to go crazy because they will feel, no, I'm not achieving the number of passes I did before to achieve the operation. The machine is not vibrating as strong as before. There's something wrong here. There's something we need to fix. Then they will go, no, the machine is wrong. We have electrical problems. You have to come here and check the machine. And then you go there and there's nothing wrong. Or there might be something wrong because they turn off seismic and they turn normal vibration on, and then they start damaging the machine because going high amplitude all the time. So that's one point that you have to make sure before going fully in the technology side.
Mm-hmm.
I remember we had 6 machines. Well, I don't know if I mentioned this before, but actually I'm Peruvian. So in Peru we had these 6 machines. DCO machines. I was not still in Dynapack, but I was in the Atlas Copco group when Dynapack was part of the Atlas Copco group, and we were having this customer complaining about the DCO, and every time we went, it was an application issue because the customer was moving to manual vibration. The operator was moving to manual vibration in order to avoid the, how do you call this, the lack of energy, let's say, the operator feeling like, no, the machine is losing power. We went there, it's not losing power, it's fine. We went back, and then we went back again to the field because the operator was calling, and the problem was they using high amplitude, they start destroying several parts in the machine. So it's quite important, you have to check on this one. Maybe you can take this one, Murilo, because I'm getting a lot of thirsty.
Can I change amplitude without changing frequency? Yes, we can. Normally, it's used in the CA equipments. The frequency is the same, but like one CA 250, the frequency is the same in high and low amplitude. What we change is only the amplitude. It's made change the rotation from the rotation side. Can I talk? And the right, or from the left side of the rotation inside the cylinder. Then we
The eccentric.
the eccentric, yes, the eccentric rotation.
Yeah, so actually it's that, as Murilo is saying, when you change the eccentric rotation direction, you will have higher or lower amplitude. So you don't, the frequency is one. And now we have these machines that can change independently the frequency, and it will somehow affect the vibration itself, of the amplitude itself. But you can go high, low, depending. You can activate it in the operator's panel, or you can out here in the. I don't know if you're referring to the seismic, because here it's going to change the frequency itself, and it will change the amplitude by changing the frequency. Okay.
Yeah, it's completely different.
It's a completely different technology. It's not the same as we use in a normal CA, that we can select the amplitude or we can select the frequency maybe. Okay, I know the CA 250D, they have a vibration tab that you can change the frequency, but it's completely different technology when we're talking about seismic. Okay. Don't know if you have more questions. I think we've done more questions than the previous presentation. Please. I already running 2 hours, so I will close the presentation now. So we have more presentations. We're starting now the day here. It's 8 a.m. here in Brazil, so we have to also do some job here. Thank you very much for your participation, Murilo. Thank you very much to all of you that participated in this training. Please do not miss the workshops, the upcoming workshops. Thanks to all. Okay. See you, Murilo.
So, see you.
Oh, do not forget to send any questions or pending doubts to my email. I will try to answer them. If I don't have the answer, I will talk with Murilo and try to answer them. And if we don't have the answer, well, we will find the answer anyway. Thank you very much. Bye-bye to all.
The story of Dynapack begins in 1930 with the foundation of AB Vibro Beton, a company specialized in vibration technologies. Since then, product development has been one of our main focus areas. It enabled us to develop the world's first self-propelled compactor. Decades later, this machine has evolved into a 6th-generation family of rollers that still leads the field. In 1973, we changed our name to Dynapack, short for Dynamic Compaction, turning our reputation into a strong and committed brand. Over the years, our pavers, material feeders and other machines also became known for their reliability and performance. Equipped with Dynapack innovations, our machines enable customers around the world to achieve better results. Advanced machine technologies combined with digital solutions increase uptime and ensure the highest quality and efficiency. Strategically located production units and distribution centers, as well as a global sales and service network, provide the assurance of Dynapack support in more than 150 countries. And yet, our story still isn't finished. under the wings of Fiat, our next chapter begins. We have a new visual identity with colors that express the spirit of Dynapack and our passion for innovation. An identity that signals our independence as a brand, with our own technologies and products and dedicated Dynapack channels focused on helping our customers. Innovation is fundamental to the Fiat strategy. As part of a group with extensive knowledge on road construction equipment and the ambition to be a technology leader, we can create better solutions for the challenges our customers face. Within the Fiat Group, we can achieve development and sourcing synergies to strengthen our own engineering and production capabilities. This will enable us to extend our offer with new products, services, and digital solutions. Like Dynapack, Fiat knows that great support is the key to customer loyalty. So we'll seize this opportunity to build and focus our service organization, ensuring our customers always come first. In short, the Road Equipment division of the Fiat Group provides us the framework and stability that will allow us to innovate and grow. A bright new chapter that will enable us to be a reliable partner who helps its customers pave the way to success. A promising future for the continuing story of Dynapack. Dynapack, your partner on the road ahead. The story of Dynapack begins in 1934 with the foundation of AB Vibro Beton, a company specialized in vibration technologies. Since then, product development has been one of our main focus areas. It enabled us to develop